be worth taking a picture of.
Yes, exactly. Take a picture of them.
Yes, yes. Can we get a picture of all of you looking that way? Seriously? Do you send me the picture? Yes. You not bring my No, I'm really regretting not having had my camera.
That's going to be the front page.
Yeah.
Let's take a picture of the crowd.
Yeah.
Okay. Welcome to this press conference and the Royal Swedish Academy of Sciences, and of course a special welcome to our laureates. My name is Ellegren. I'm the Secretary General of the Academy. And closest to me, we find this year's laureate in economic sciences. First, Professor Daron Acemoglu, Professor Simon Johnson, and Professor James Robinson. Next to them, you will have the Nobel laureates in chemistry, Professor David Baker, Dr. Demis Hassabis, and Dr. John Jumper. And next to them comes the Nobel laureates in physics, Professor Geoffrey Hinton, and the other physics laureate, Professor Hopfield. He is elderly and he needs his rest, so he is not taking part of this press conference. During this press conference, you are welcome to ask questions to one or several of our laureates. You can take this opportunity to hear their views about their research, how it is to become a Nobel laureate, questions about science in general, etc. Questions are asked in English, and when you want to ask a question, raise your hand, and we have staff who will come with a mic, so you have to wait for getting a mic to start the questioning. By this, I open the press conference. Who would like to start? Please.
Hello. I'm Digital EU Ambassador, and my first question is to Professor Geoffrey Hinton. You are the father of artificial neural networks. When you look at AI development today, do you regret something? If you could turn back time, would you do this? And my second question to Professor Geoffrey Hinton and Demis Hassabis, do you deeply believe that something like a superhuman's AI exists if we ever achieve this level, or it's the marketing tick of big tech and huge companies? Thank you.
Let me answer the second question first. I think both Demis and I believe we are going to get superintelligence. It's not hype, and it's not designed to distract from other problems with AI. It's what we have believed for a long time. Now, I thought it would be much further away, but the speed of recent developments means I think it's going to be quite soon. I think between 5 and 20 years. I think Demis thinks in about 10 years, we'll get something like superintelligence. And we have to worry seriously about how we stay in control then. Back to the first question. There's two kinds of regret. There's guilty regret when you did something and at the time you knew you shouldn't have done it. I don't have any of that. If in the same circumstances, I would do the same again. However, I think it might have been unfortunate in that we're going to get superintelligence faster than I thought, and I wish I'd thought about safety earlier.
Well, I agree with what Professor Hinton's just said, and for us, actually, starting a DeepMind back in 2010, we did sort of think through what would happen if we built these kinds of intelligences. Of course, my passion is always to build these types of tools to help us with scientific discovery, as we see today. And I think we'll get amazing things out of that, cures for diseases, helping with energy, climate, a lot of the big challenges we have in front of us as humanity today. But we've always been cognizant as well of the risks that come with any powerful general purpose technology. And I think AI will be one of the most powerful, if not the most powerful technologies humanity will ever invent. So we need to take those risks very seriously. And there isn't a lot of time to do the research and required to think about things like interpreting the systems and controlling those systems. But it's also a societal question about, not just a technological question, about what do we want to use these systems for, how do we want to deploy them, and making sure that all of humanity benefits from these, what these systems can do.
Simon Campanello.
Thank you. I have a question for the same two laureates, Demis, Hassabis, and Geoffrey, Hinton. Do you think that we need more AI regulation in order to make safe AI?
So a point to make first is that one of the shorter-term dangers of AI is the development of lethal autonomous weapons, and there isn't going to be any regulation there. If you look at the European regulations, for example, they have a specific clause in them that says none of these regulations apply to military uses of AI. So governments are unwilling to regulate themselves when it comes to lethal autonomous weapons. And there is an arms race going on between all the major arms suppliers, like the United States, China, Russia, Britain, Israel, and possibly even Sweden, though I don't know.
I think AI is very important technology to regulate, but I think it's very important that we get the regulations right. And I think that's the hard thing at the moment, is it's such a fast-moving technology and evolving so quickly. What we would have discussed regulating a few years ago is not what we would be thinking about regulating now. So what I've been advising governments and civil society to do is to have fast and nimble regulations, maybe build on the regulations in domains that we already have regulations in, like healthcare and transport and so on, and see how the technology develops and then quickly adapt to the way that's going.
Professor Acemoglu, if I may ask you, you are awarded for something completely else, but you're also become interested in AI. Do you have a comment you want to raise here?
Well, I mean, there are great experts on AI here, so I wouldn't compare my knowledge in any way to theirs. But I do think that there are a lot of excellent and very productive uses of AI, and a lot of dangers and socially destructive uses of AI that you will get regardless of whether we reach artificial general intelligence within the next 5 to 20 years. And worrying about these regulations is first order for all kinds of societies. And it's a very, very difficult problem, both because of the fast-moving nature of AI, the international nature of advances and the deployment, and the fact that we have very little experience of regulation in such areas. And I think part of the consequence of that is that a lot of the regulation that we are thinking of is reactive. So the industry or something else happens in AI, and then we react in order to try to minimize the risks or the potential social damages. But given how disruptive, important, and pervasive AI is going to be, I think we do need some more proactive regulations, meaning thinking about what it is the direction of AI that is socially more beneficial, which aspects of this we can build a broad social consensus around, and how could that be implemented in a multipolar, complex world. But I think it is first order important, and in some sense, in my mind, it is as important, if not more important, than sort of worrying about AI safety that is in a forward-looking manner. I'm not saying that's not important, but you know, within the next 5 years, there are many more aspects of our social lives, economic lives that are going to be impacted by AI as we have it today, or as it will develop within the next 5 years or so, well short of the artificial general intelligence. So I think that has to be a very important part of our concerns.
Please, there. No, you.
Good morning, I'm Corina Negra from Radio Romania, Science Department. I have 2.5 questions. So we are speaking about regulation instead of banning. And I'm asking this because there are a lot of talks today about banning or not TikTok, for example. David Baker, Gary Rafkan was telling yesterday that we would have been better today if we wouldn't have had social networks. So should we ban or should we regulate strictly? The second question is if the scientist shouldn't be worried about using AI when there is so much scientific fraud today and we are finding out about misconduct. Can we trust AI? And the third question, if it's possible, is there any, this is for the economics laureates, is there any example, the best example where social institutions, statal institutions did the best in their duties? Thank you.
There were 3 questions. Maybe we take just one question at a time here. But one of the economics laureates, do you want to address the third question? Simon, or?
So when you said did better, in what specific context with regard to regulation of technology, or?
No. Economically speaking, is there any system in this world that is the most successful system, economically speaking?
Sure, I think that I hesitate because I'm aware this statement has become controversial, but it seems quite obvious to us from our research and practical experience that democracies and democratic systems in which governance is shared, there are what we call inclusive institutions, there's broad access to property rights and political rights across the population. These systems have outperformed all the alternatives that have been put forward over the past 400 years. Sure, it's bumpy sometimes, democracies go up and down, some democracies are more volatile than others, but democratic systems with inclusive institutions have massively outperformed all the competition over long periods of time. Challenges come and go, but at least speaking personally, my co-authors speak for themselves, I'm confident that the future of the world and the future of technology will be better if we continue to strengthen all our democratic institutions.
Professor Robinson, do you want to also add a comment there? No.
I agree with that.
Yeah. Professor Baker, did you have an answer to one of the other questions?
Not particularly.
No. Who shall we take first here?
Hello, it's Ivan Semenek with the Globe and Mail in Canada. A question for the economics laureates is, because your work involves different outcomes for societies, some are more prosperous, some are less prosperous, how you view AI and these new technologies as potentially exacerbating those differences, or could it somehow be harnessed to improve outcomes, to reduce the distances? I also have a question for the science laureates, whether they feel that AI has now officially arrived as a full partner in research, and will we now see AI represented in future Nobels, or will it simply fade into the background as a given that every science project involves AI? So 2 separate questions.
Professor Robinson, do you want to take the first one?
Yeah, I mean, I'm not an expert on AI, but I do work in a lot of poor countries where there's no electricity and there's no computers. So I'm a fellow of the Institute of African Studies at the University of Nigeria, and there's neither power nor computers nor internet. So just kind of normalize a little bit. I think, of course, these technologies are potentially fabulous for poor countries, but in a country like Nigeria or the Democratic Republic of Congo, there's just basic things that we've understood how to do for hundreds of years that are not in place, like electricity or basic infrastructure, running water, So you don't need AI, to understand how important those things are for people's lives and people's welfare. And I think a lot of our work, my work, has focused on trying to understand why doesn't that happen? Why is it so difficult to do something which everybody wants and which everybody knows is fabulous for people's welfare. As I said, I'm not an expert on AI. I'm sure AI and many other technologies are potentially life-changing for people in the developing world. But there's just fundamental problems of how you organize society and institutions and politics to kind of even adopt and use these technologies effectively?
Professor Acemoglu?
Yeah, I'll just say something. Thank you for the question. Today there are really staggering differences between countries. In this hyper-connected, globalized world, some of the richest countries are 60, 70 times as rich per capita as some of the poorest countries. Look at before the Industrial Revolution, those gaps were perhaps 3- or 4-fold. Disruptive technological changes or disruptive events often have the effect of creating new divergences. Industrial Revolution was definitely one, world wars. And I think AI promises to be a disruptive one for good and bad. So there is a danger that it will actually widen a lot of gaps. The potential is there, I think, to use AI in ways that could help developing countries, as is quite possible to use AI as an information technology to help workers who are falling behind, students who are falling behind. But I do remain very worried that that's not the direction we're going, and the way in which AI is concentrated in the hands of a very, 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 very small number of people in an extremely oligarchic, oligopolistic setting and in the hands of a very few countries is going to be a further impetus to much greater inequalities.
Dr. Jumper, there was also a question there about the future of Nobel Prizes and AI.
I think it will be a mix, and I think ultimately the prize in chemistry, of course, the citation is for protein structure prediction and for protein design. And I think it's really important to say not for AI-driven protein structure prediction. If we had come up with an entirely, I used to work in physics simulation, if we had come up with a physics simulation method that achieved similar accuracy, I imagine that group of inventors would be on this dais. It's really about what AI is enabling, and this was the tool that we were able to use. And I think David's work is also beautiful, where he has beautiful designs like Top 7 that are really pre-AI or with a more kind of physics focus, and then excellent post-AI designs as well. AI is a really, really powerful tool, like a new type of microscope, like a new type of way of getting some information about the world, but we confirm it with experiments. We use it to do the same types of problems as we have before. We maybe even have new problems that look approachable now. And so I think we will see more and more AI pop up as a step within the process, or even the main step within the process of the people that appear for future Nobels, but they won't get it because they brought AI to it. Right? It's not just about funding, it's about the discovery, and they will get it because of the discovery. And hopefully even, and the one I really look forward to is when someone is up here where, for example, using AlphaFold or another protein structure prediction tool was the decisive step in them discovering something new about how the cell works, and they're up here for knowing how the cell works.
Mm-hmm. Want to comment, Professor Baker?
Yeah, I think AI is incredibly powerful, but it should be recognized that deep learning methods require really large and well-curated data sets, and the three of us really benefited from 60 years of hard work by tens of thousands of scientists and tens of billions of dollars of investment in solving protein structures experimentally. And so in a sense, we had this incredible resource there that generations of scientists had put together, and that was why, that certainly made it possible to apply powerful deep learning methods to solve these problems. And so in terms of thinking about how AI and deep learning methods sort of progress to extend to science more generally, I think part of that will depend on the extent to which data sets are available or generated of considerable richness in other areas. For example, as we move up the biological complexity ladder, there are obviously huge numbers of unanswered questions. There are data sets. Questions are the data sets really comparable in their depth and richness? And the answer is probably no. So I think it's not just the methods; it's also the data that is really important.
Mm-hmm. Please, only one question per person now. Please.
Hi, I'm Azasa Nakanishi from Japanese newspaper Yomiuri Shimbun. I have a question for Sir Demis Hassabis. Some authorities are concerned about the partnership between big tech and AI developers, which could lead to monopolization in AI fields. but AI developer need for a significant fund. So what's your opinion on about the risk of monopolization and concentration in AI fields? Thank you.
Yeah, look, so AI, today's modern AI does require a lot of resources, especially compute resources, and it's very expensive. But a lot of the models that are produced by that are then open source or very easily available off the shelf almost to almost anybody to use it, including a lot of the tools that we've built. So I think there's a lot of democratization of the technology. It's diffusing very, very quickly. So I think going back to some of the earlier questions as well, I think we're going to, of course, I've worked my whole career on AI because I believe it will be one of the most useful and powerful tools for advancing human knowledge in all sorts of important fields, obviously biology, but medicine, material science. I think we're on the cusp of a new golden era of discovery that's helped by and powered by some of these AI tools. But of course, there's a dual purpose technology. It's a general purpose technology. So there are risks of bad actors repurposing these tools for harmful ends. And I think then it becomes more societal question of how do we make sure we give access to as many good use cases as possible while restricting those same technologies being used for harmful ends. And it's very difficult. Like there's no easy answer to that. And I think we have to work through those questions. And I think we also need to do a lot more research on the technology itself so that we can understand these technologies better. AI is an engineering science, which means that you actually have to build the artifact first that you're interested to study, and then you can break it down with a scientific method. And I think we've just got to the point now where for the first time, maybe in the last few years, we have AI systems that are doing interesting enough things that they're worthy of study and in their own right. And so I think over the next few years, a lot of the work the field needs to do is to build those tools to understand and interpret what these systems are doing, and that will give us a better idea of how to control them and put guardrails on them to make sure that we get the benefits and mitigate the risks. But it's a complicated question that I think is not just a technology question, but it's something the international community needs to come together on, I think, and collaborate on. And some of those kinds of international summits are starting to happen now, and I think we need a lot more of that kind of dialogue because it's going to affect the whole world, not just individual countries.
Mm-hmm. Time is running, but we have a question here, please.
My name is Marta Patellini from La Stampa, Italy. I have a scientific question to the chemistry prize, which is if you give two researchers to design the same thing, do you get the same results? And how do you move forward scientifically?
Let's see. So if you give two researchers the same problem to solve, and say it's a protein design problem, you will get different proteins designed, but that's because there's a very large family of possible solutions to any design problem. It's like giving two architects the job of building a house with some certain number of rooms. So you will get different solutions, but that's not a bad thing. It's you're not learning something about reality. You're trying to solve a problem, and for any problem there will be multiple solutions, which can all be roughly equivalently good.
Mm-hmm. Maybe one final question. Yes, please, here.
So I have a question for Dr. Jumper. In building these advanced machine learning systems, the use of domain knowledge is often very important to succeed. And I wonder if you could talk a little bit about the process of integrating your domain knowledge into a team of deep learning experts, basically. And also if there were anything there that went more smoothly than you expected, or if there were some parts that were more challenging and caught you by surprise. Thank you very much.
Well, thank you. That's a really interesting question. I think really an AlphaFold represents a system where, as David says, we have this collected body of knowledge. We had about, I think, 160,000 structures available, and each one is an enormous amount of effort. It is a fixed, incredibly precious resource. And so putting domain knowledge into how we build the machine learning system gave us about 100-fold data improvement in efficiency between AlphaFold 1 and AlphaFold 2. This was measured by an independent lab. And I think what turned out to be more challenging and in some ways less challenging, less challenging in the sense that it works so well that I get to sit up here, but more challenging maybe than we thought is exactly how you express those physical principles. What are the right principles to put in your machine learning? Which ones are somehow too explicit or you're just telling it things that the machine learning can't miss from the data? And which things are really, really essential? And we find things like communication patterns, and it's relatively technical for this, but it was very interesting to kind of build the intuition of what does machine learning and proteins as a joint field look like. In terms of bringing expertise, that was actually easier than expected. We started out, I had trained as kind of originally a physicist, but had picked up biophysics in my PhD. But what I found is that the scientists at DeepMind were really keen and eager and excited to learn about biology. And it was much easier to bring a group of kind of physicists, computer scientists, over to learn more about biology, supplemented by I'm an okay biologist and Catherine is an excellent one, was much easier to kind of bring them to this broad field and they could learn this and dive into how these data work. And I thought it was really, I was impressed at how smoothly that went and what a superpower that became for the team of having, 15 mixed experts because they started from one side and became mixed experts.
Maybe I can just add on that's was the whole purpose behind DeepMind, was to encourage multidisciplinary research. I actually believe that that's going to be one of the major places where advances are going to be made in the next 10 years is the kind of combination of 2 or more fields. And that's exactly what happened with AlphaFold, and it was necessary for that to be successful.
Time is flying, so that was our last question. I think several of you will have individual interviews with the laureates. I hope we can start with that as soon as possible. Thank you for your interest coming here, and I hope that as many as possible of you will be able to attend the Nobel lectures tomorrow. So thank you.